Hey everyone, welcome back to the Codezilla and today's lecture 4 of learning coding. So today we will be doing one more algorithm for the sorting. Previously we have done three of them. Today is the fourth one and it is the one of most prominent one. You might have heard about it. It is none other than merge sort. So in merge sort, we can say it is a divide and rule and all those stuff. But in the interview, they might ask us write algorithm to do a merge sort. And if they ask us to do sorting in a reverse order. Like we usually do it in ascending order, and if they tell us to do it in descending order, then in middle sort might not work because it will be sorting in ascending order and we want in descending. So we have to do tweaks in our sorting algorithm. So for that, we will be going to merge. And we will also understand why we need merge sort because we already did few of algorithms which are running like big O of n square times it is running. So those are fine. So then why we need this? Is it way more optimized or is it like having less time complexity or how will it approach? So now let's understand merge sort in a brief. Earlier, I used to use like code in an online compiler because what I will be doing is I will be coding in all of the environments. Like there are different environments which we have to set up, and we have to learn how to code in all of those environments. So earlier I did it in online compiler. Now I will be doing it in my local machinery, and further I will be doing it in any of the online competitive compiler like LeetCode or someone else where the question is already framed for the quick sort one or the further algorithms, whatever we do. Just for this merge sort, now let's learn how to do a merge sort or what a merge sort is. So starting off, as we have done three algorithms previously, like first one is the selection sort. So from selection sort, you might have understood like why we use selection sort at first because it have the worst time complexity. Like big O of n square is the worst time complexity, and it will be for all the cases, like for the good, worst, best, all the test cases. All the cases, it will be giving us big O of n square time complexity, which is not a good another algorithm. Okay, so that one that then we came towards the bubble sort. We implemented the bubble sort. It worked fine. We did some tweaks with which it become bit more optimized, bit more. This is the code for it, but here also you can see that we are using two for loops, and the worst case it will be big O of n square only. And one thing to keep in mind, the big O notation is for the worst cases we have to take. We didn't take for average or we didn't take for the best case. We take for the worst. Then we came to the insertion sort. In insertion sort also we did some tweaks and we are using a while loop. So at a point whenever a array becomes sorted, because we are iterating from back, we are using a greedy approach there. So whenever our array got sorted, we didn't do any more operations, and it is optimized in specific cases, but still the notation or the time complexity is still big of n square. So why we need another algorithm? Because everything is working fine in certain sort. We did some of the like here and there, and it is like good for some of the cases. But why we need? Because merge sort will be doing it in a way more better time complexity than this. So now let's understand the merge sort. So merge sort. It is, I think this algorithm might be developed by the Britishers because it is like divide and rule. So how British have conquered us by doing divide and then rule, we'll be doing this same approach only. So we can say that merge sort is divide and rule, and let's see like how it will divide and how it will it will actually rule, like how it will do all those stuff. So now let's understand. Let's select a color. So yeah. So Mersot, as I said, you can say in the beginning only like it is divide and rule algorithm. So from divide and rule, what are the things which you are getting in your mind? It means an array will be there for sure, and we have to divide that array into different parts and then merge them from the merged. So that is the main approach for this. So what will be happening here is let's suppose just as an we have an array which has some values inside it. So we can do is what we can do is instead of using two for loops and all the stuff, what we can do is we can just go here and what we will be doing is we will be just dividing it at the first instance. We will be keeping two pointers. Let's suppose it is low pointer This is our high pointer. So what we will be doing? Low and high pointer we will be having, like we can take it from the array size, like it will be at high, and low pointer will be at zeroth of 10. The mid will be find out with the help of low and high. We can simply take the average, like high plus low divided by 2. It will be giving us the mid, just a simple math algorithm. Although we will be doing a tweak in this also. We will doing it while doing the coding. Like I will be using something else other than this, and I will be telling why I'm using that to find the mid. So I will be finding a mid also. What I will be doing is, once I found this, I will take this portion. I will take this portion in a separate. First, I will take this and I will make my mid as an high. So if I have already divided it, so it will become low, and here will be mid, and it will be mid plus 1, and here will be our high. So we have divided our problems into different parts. This is the main approach. Whenever you have to solve a bigger thing, you have to divide your things into smaller part and then start solving it. Then again we will divide it off, low, and we will be taking average of this low plus mid divided by 2, which will be our, we can say, new mid. So this new mid will be here, and what we will be getting is low, new mid, and new mid to our mid. Again we have divided this. So in same way we will be iterating in in this way also, like low high mid pointers, and just dividing our problem till we get a single element. And then the main algorithm will start, which is to merge. While merging, what is the thing which we will be taking in consideration is, we can compare two elements for sure, like if we keep on dividing, and then we can compare, and then we can merge it off. So what we can do till we get till the end, like after this no merge can be happened, there is only one element which is there is only one element which is here, so we can't merge it more. Then we will start our main algorithm, which is doing the merge off. So in merge function, we will making another function merge. What it will be doing, it will be comparing both of the elements. It will be comparing like ARR of low and the other element ARR of mid, or whatever it is. It will be comparing first whatever is the smallest, whatever is the smallest, it will be swapping it at the first. Whatever will be the smallest, because we want it to be in ascending order at first. So just by, like, I will just edit a single word, a single symbol. I will edit a single symbol in my code, and it will do it in descending order also. So ARR low, ARR, whatever will be the low, I will be pushing, or I will be making that element at the first. I will be making that element in the first. So for that, what I can do is, like, for sure, while doing the code, I will be telling you each of the steps, like why I am doing this and why I am doing that. So I will be taking temp or whatever it is, and I will be pushing back that element. I will be pushing back that element, and from that, I will be pushing back whatever will be the uh, small. If this will happen, I will write it in if else condition for sure. That is journal approach. Like if, and then in the else condition, I will be doing same thing, but here instead of low, I will be writing ARR of mid or something else, like whatever we have. So in this way, we will be merging it back also. So the two steps, the two prominent steps which you have to tell to the interviewer or whatever, whenever we have to explain it to someone. Firstly, we will be dividing it out, dividing it till we get to the end, and then merging it back, and then swapping it on the basis of the smallest or basis of the greatest, whatever we want in the way we want. So in this way, the merge sort will be implemented. This is the brief about the more sort of like how it will be implemented. So from the like intuition or from the explanation, you might be get confused, like Hey Satyam, like what is happening here? Like merge is here, and when we are merging it, then how will it compare and how will it swap the element, or how will it push those elements which are smallest at the beginning, and how will this all happen? Like how can we divide it? We have to write this code again and again. No, we will be using recursion. We will be recursively calling it. And now let's see in the code like how we can implement this, and I will be telling you each of the steps one by one. You have to just keep these things in your mind and then you can easily solve the problem. So now let's go to the my local machine and then see how we can firstly set up the environment for this. So firstly, let me write a new file. Instead of a file, let's make a folder. In this I will be making a folder merge. So right now we are in the merge folder. Here I will be going, and then you have to make a file named as named with the extension .cpp for C++ for short. You can use any of the languages which you want, but the mouse sort will be same. The approach will be same. The intuition will be same. The like how you have to explain is the same. The syntax is different. This is the only thing. Then you have to write the first thing like include bits slash stdc, and it is done. Yeah. So we will be including this specific library like bits std plus plus dot h. So what it will be doing, it will be installing all the things which we want. So we didn't need to do anything else. All of the compilers, like online compilers or competitive compilers, these are already installed there. But still, when we have to do it in our local machine, we have to establish everything by our own. We have to make main function and all the stuff. So we have to do it by ourselves only. So name using namespace std, so we didn't have to write that std dot and then writing the whole code. Now, first thing for sure, like int main, and with the main, what we have to do, we have to return 0. Why we are returning 0? Because it is an int function. Like it is a main function, although it is the entry point of the code. If you will learn any of the Jack language or any of the low level languages, then you will understand like how this thing will work, like why we have to return and all that stuff. So it is an int main, so we have to return for sure something from it. It doesn't trust us. It have a trust issue, we can say. So now let's enter to the main function, and what we have to do is let's suppose firstly introduce as to just implement the merge sort for ascending order, and then do it, then do a single change and do it in descending order. So firstly, in the most of the compilers or most of the thing, like most of the competitive coding rounds, also vector int will be used for sure. Like it is the most prominent thing to be used. Reason is simple because every time they have to give different values to you. Here I am just importing the values because in my previous videos I have already told you like how we can take the inputs also, like doing sin and all the stuff. But here just do it with the simple compiler run. So here I will be doing some of the complications and then it's done. Okay. So now here you can see that I have already initialized the vector int, which is ARR, which I have poured out right now the values which are I have pre-written values around there, and we have to sort it out. Now let's see how we will approach to this problem. So what we have to do is we have to pass it as a reference for sure in the upcoming functions. So what we can do is we can make a helper function, and this will be taking a input of vector int ARR, and I will be using this and sign, ampersand sign. The reason of using it, it will be passed now as a reference here. So passing it as a reference, it means like it will be not making copying of copies of it. Instead of it will be passing it as a pointer reference, like memory address reference. So it changes will be directly implemented to our main array. Although, what are the things I have told you in the beginning only while explaining the code? Like we have to take low and high. So just take low and high. Int low, it will be 0. I have told you in the beginning only, like low will be this int ARR, sorry, int high, which will be ARR dot size, whatever the size of it, and -1 because zero based indexing is there, so last will be one less than the size. It is general like knowledge which you should have. Helper function, array will be going there, low pointer will be going there, high pointer will be going there, and it is done. We have to do nothing else because it is giving error right now because I didn't initialize So if I do here int I, so now it will be fine, like no worries, it is fine. And then what we want to do, let's make a for loop int x, which will be arr out, and it will be x. Yeah, so it will be done. So in the problem or in the competitive rounds, there will be, you didn't have to write this for sure. Like most of the things, it will be written. You would directly have to write the helper function, and you didn't have to do C out and all the stuff. You have to just return the values, or you have to just sort it off, and it's done. But here, just for our visibility, like can we do this? Just for that purpose, we are right now doing this. So see out excellent, just giving a space so that every element will be printed at the end after it gets sorted. After it gets sorted, then we will be doing it. Now let's move to the next step with what we have to do. Now we have to divide it off. I have told you about the mid. Like we will be taking a mid thing in our mind. But still we have to think about another thing, the cases or the base cases, because we will be using recursion. And while you using recursion, you have to take one thing in mind, that is for sure, before writing even recursion or before thinking about the recursion, you have to think about the base case. Otherwise, it will end in the infinite loop and you will not get the answer. Uh, it will get like Stack Overflow and you will not get your answer. So we have to write a base case for this. Now, what can be a base case of dividing it off and all the stuff? We can say if our low is less than our high, then only we can do it. Just suppose if our we are shrinking our array and it will be going in reverse, like low will be going further than our high. If our starting is greater than our ending, it is not possible. Low we can take it as start and we can take high as our end. So whatever it is, start should be less than end for sure at any cost. So that we will be taking. So if our low will be less than high, if our low is less than high, then only we will be doing it. Otherwise, we will be returning back. It is a void function, so we didn't have to return anything. We can simply return it and it will be returned. So now let's implement the mid first. Now, for the general case, like this is a small one, I can write simply like left, sorry, low plus high, and then like just writing this bracket and then dividing it by 2. It is just like simple way to find a mid. But but if there is a longer uh, if there is a longer case which will be given, because there are many cases which are given out there, so at that point what we have to do is we have to make it in a different way so that it will not take that much space. Because what happens if the integer which they have written here is of maximum length which is possible in our system or in the compiler, and we have both of them, like left is also that much big, right is also that much big. So if we add first both of them, then it will be going overlapping it will be overlapping it. So for that we will be using left plus right minus left, or sorry, I wrote that left right. So instead of that, low will be the perfect one. So low plus high minus low, and then dividing it by 2. It will be giving us mid only. But here what will happen? It will not add in the first instance. It will not add up in the first instance. Instead of that, it will get subtracted. So we will be in our range only of range of integers. That's what we can do. Now let's do the recursion. Now let's put the recursion. So what I have told you, like what we have to do is we have to take a mid, done, mid is done. Now we have to divide it off from low to mid and then mid plus 1 to higher. How we can do it? Array will be going in similar way, low will be going there, and then there will be mid. Instead of high, we will be sending mid. So what will happen? This helper function will be calling array only, low and high. So high will be converting it to mid. So now there is a new high, which is the mid value. So it will be an like it will be sort of an dividing what we have to do. So then again we will be calling the helper. Then we are calling this, and then mid plus one, starting from one more than the mid till our high, till our high. So a new start will be there. So now The divide is done, but the main part is the merge, which we have to do. So void merge, and then now let's implement the merge. So if I write merge, what are the things which we have to pass to the merge? So merge as a function, it wants the array for sure. It wants the low also. It wants the mid also. It wants the high also. So it will be taking all of the parameters. Now let's write all of them. So we have already written parameters here. So we will be calling it recursively. And along with that, we can write int mid. Yeah. So now there is no such errors which we have. Now we have to start implementing our code. Firstly, uh, we have been dividing it. We will be dividing it till the last elements are left, till the left is smaller than right. Now we have to think about the merge. As I've told you, like there will be a attempt in which we'll be pushing it back, and then we have to then copy it back also. And there will be if condition with whatever is the smallest between low and the mid or mid plus one, we have to add that first. So now firstly, let's make the temp only. So we have to make that temp. So for that, now let's make it here. Sorry, int temp. So vector int temp will be here. Now what we have to do is let's take some more pointers like left and a right also. Left side and right side. Left will be first for sure pointing towards the low. Right will be pointing towards the mid plus one. So we will be having two starting points. Just as simple as that. We left will be like simple pointing, and we didn't change the things which are been coming from the another function. Now we have to add a while loop. While oh wait, we have to write a while loop while our left is less than the mid, or we can say equals to mid, means left should be in its limits for sure, and along with that our right, it should also be in limits. It should also be less than or equals to in that. Now what we have to do is we have to do the comparison right here only. If my array of left element is less than ARR of right, just forgot everything and just push it back. So that we have to do. We have to just do temp dot push back, and then what we have to push back in the array, that is the main thing. So right now we are doing it in ascending order, so what we have to push back here is ARR of left. ARR of left will be the thing which we have to push back into our vector int temp. So it will be pushed back, and in the else condition what will be going there is ARR of uh, ARR of left. We didn't have to compare now. If it is not less than, then right will be for sure. So we will be doing temp dot push back, and then doing ARR of right for sure. Now it's done. Uh, we have successfully compared both of them. So we have pushed the elements, and now what is left? But still there might be a case. What if our one side get exhausted first and other will not? Other is there are some elements still left in the left or right side. So for that we have to write while condition again. While our, so it will be just like similar to the previous one, while our left is less than or equals to our mid. Till then, what we will be doing, we will be doing same thing for pushback, and then ARR of left, and then just increasing our left also. That is for sure one thing, because it will end in the infinite loop. Increasing left, increasing right, so that it will be checking for the next elements which are upcoming ones. Similar we have to write for the other one also, which is uh, our right. So till our right is less than equals to we can say high, which, so high, so till then we have to push back the right one here, and then we have to increase the right. So once both of them get exhausted, then what we have to do? Then we have to write a for loop which will be running from uh, I equals to 0 and going till our like temp dot dot size and then I plus plus. Now we have to copy back the elements. Now, as I have told you, after this we have to copy back the elements that in our main array. So we will be doing this. Low pointer will be here. What we will be doing, low pointer should be equals to our temp ith element. So it will be like one by one. It will be increasing it. So and that's all what we have to do. Then we will be increasing our low, and just then we have to return back. Returning back, this function is done, merge is done, our helper is done, our main function is done. Now we have to just run this problem and see. So the time complexity will be here. Like let's assume firstly run it and then see if it works or not. Yeah, here you can see that it got merged. So now if I will clear this and then again I will run this problem. So it will be giving us in a sorted order. So 1, 2, 3, 4, 5, 7, 10 will be the sorted order, and the order in which we gave it, it is not the sorted. If I have to make it a bit more complex, like 10, then 2, then 3, then 1, then 14, and then 11. Let's see if it can do this also or not. Yeah, so it is doing 1, 1, 2, 3, 10, 11, 14. That's all. Now let's analyze the time complexity. So here the time complexity will be way more lesser because we are doing divide and then we are doing the division and we will be at the end just like copying the elements. So what will the time and space complexity? So firstly talking about the time complexity, here it will be big O of n log n, which is way more lesser than big O of n square. So we get a better time complexity out here because log n, because we are just dividing it up, and the space complexity, will be big O of n, because in the worst case our temporary array which we are making it is storing. So it is a bad thing about the algorithm, like one of the bad things, because it is using a space of big O of n. But for sure, there is something else, that is the quick sort, which will be eliminating the space complexity. Time complexity will be the same, but space complexity will be get decreased in the upcoming one, which is our quick sort. So this is all. Now let's think about the tweak which I was telling. Like if we have to do it in opposite order, if we have to do it in like descending order, just do this. Just a single change. Run this again. It will be giving you in the descending order. So just a simple algorithm, divide and rule, and just done the descending order too. So that's all for the video. I hope you liked it. Thanks for watching.